Hi everyone, I just recorded the meeting. I'm going to get started. So my name is Rachel Soobitsky. I'm Geospatial Project Manager at the Chesapeake Conservancy. This presentation is on the Chesapeake Bay High Resolution Land Cover and Land Use Project. Should we go over the mission? Chesapeake Conservancy is an entrepreneurial nonprofit organization based in Annapolis, Maryland. Our mission is to conserve and restore the natural and cultural resources of the Chesapeake Bay watershed. We advance strong public and private partnerships. We develop and use new technology, and we empower environmental stewardship. Back in 2012, the Conservancy launched its Conservation Innovation Center, or the CIC, which is a team that devotes their energy towards employing emerging technologies, high-resolution data sets, and innovative methodologies to increase the effectiveness and efficiency of conservation and restoration efforts. At the Conservancy, the Conservation Innovation Center focuses on precision conservation. Precision conservation is about getting the right practices in the right places at the right scale and making sure they are working. So using technology such as remote sensing and GIS, we are helping our partners target high-priority conservation projects on the ground. Get the biggest bang for the buck. So the Chesapeake Bay Program Proposal consists of 4 different objectives. Today we're talking about Objective 1, which is the land cover and land use updates. We're partnering with the University of Vermont on this. Objective 2 is high-resolution hydrology and ditch mapping, and partnering with the University of Maryland, Baltimore County. Objective 3 is best management practice mapping and tracking, and we're partnering with Chesapeake Commons and Drexel University. And Objective 4 is just general GIS support. But today we're going to talk about Objective 1, the land cover and land use data updates. So the reason for this presentation is mainly because for stakeholder outreach. So my job as a project manager of Objective 1 is to reach out to all of the counties and states within the Chesapeake Bay watershed and inform them of the project and try to coordinate receiving planimetric data sets to help us in our data creation. We'll be talking a little bit more about planimetric data later on in the presentation. In addition, we're looking for feedback and input, so trying to connect with counties and municipalities to get feedback on the data as we go, give them updates as we are going through the project, and we're trying to make sure the data is the most useful as possible for all the counties and municipalities, and want it to be as accurate as possible. So trying to make those connections with states and counties and municipalities so that I have a contact moving forward, in addition to getting that planimetric data to help us create the data sets. Just a feedback form link here. I'm really looking for use cases of how you've used this data before to help your organization, or just ideas of how you think this data could be used to come up with an idea throughout the presentation. I will be providing these links at the end of the presentation as well. And then on the right, there's a land cover web viewer. This is so you can look at our data from the last 2013-2014 data sets that we have. You can scroll throughout the presentation, zoom into your location, and look through our data. All of the data sets will be available online to download, and they are currently online for the 2013-2014 data sets that we created. So the motivation for this data is for Chesapeake Bay program to help with the TMDL pollution reduction goals for 2025. So all of the states and Washington, D.C. that are within the Chesapeake Bay watershed have to follow this basically pollution diet. So what the total maximum daily load, or TMDL, is basically the mandated pollution diet that affects all states and counties that drain into the Chesapeake Bay watershed. However, to really track and manage these reduction goals, reliable, more precise data has really been a necessary factor, which is why Chesapeake Bay program really wanted these objectives and these data sets to be updated to help track and manage how we are going towards these goals. So for this Objective 1, our partnership with Chesapeake Bay Program, Conservation Innovation Center at Chesapeake Conservancy, which is me, and then at the University of Vermont Spatial Analysis Lab is our partner as well. So the previously available data, this is the National Land Cover Data Set from 2011. It is 30-meter resolution. So over Washington, D.C., and you can see the coarse resolution here. This data set is the most commonly and widely used. It's across the entire United States. However, it is from 2011. I think there will be a 2017 update coming soon. However, I'm not sure when that will be available for use. Right now, it's a little bit outdated. It's very coarse resolution. If we overlay our 1-meter resolution data, you can see It is a lot higher resolution. It's 1 meter over the entire Chesapeake Bay watershed, and every county that touches the watershed, we will create land cover for the entire county. So back for 2013-2014, and for the update to that, it is over 100,000 square miles of land cover. You can see a lot more fine details, such as like trees and street level and what's going on these parcels or buildings in each block. It really has some parcel scale management. Again, on the left, that is the 100,000 square miles of land cover we created. The purple line is the Chesapeake Bay watershed border, and you can see that the land cover extends out past that, including all of the counties that touch the border. And then zoomed in on the right is an area that has the National Land Cover Data Set. Zoomed in at a parcel in Maryland. You can see that it's pretty coarse, you can't see much detail, so if you're trying to put in a conservation or restoration project, it would be hard to just use the data itself to identify the best location. However, if you put it over our 1 meter resolution land cover data, you can now see that there's a stream that goes through the property that does not have trees planted next to it. And a best management practice would be a riparian buffer, which is basically trees right up against the stream that will help filter pollution as it would flow into the stream. So this would be a great way, to plan at a parcel scale with more detail. So I'm going to go through a little bit of the steps of our project. So currently we're working on a hotspot land cover update or change detection, which basically means that we're looking over the entire Chesapeake Bay watershed and identifying areas that have changed the most or the most dramatically from 2013/2014 to 2017-2018. So once we identify areas in the bay that have changed the most, we will update the land cover in those sections first. Once we've then gone through and done the wall-to-wall land cover, we will perform a change detection wall-to-wall. So basically, what was the land cover and what did the land cover change to? So in these screenshots, it's showing that, for example, it will be low vegetation that changes to structures, impervious, roads, etc. So we're going to do that bay-wide after, but currently we're just doing a hotspot. And this is really to help put into some Chesapeake Bay program models sooner than waiting for the entire land cover wall-to-wall to be created. And then after the land cover updates, University of Vermont is leading the efforts in this part. So they use the eCognition software usually, and so they put different images into it. So for the first one, on the top left is orange and purple. That is Lidar data set. So we're collecting the most recent Lidar. If there is Lidar over an area, we will use that and have hopefully the most up-to-date Lidar that's available. And that helps get the tree height and the building height and differentiate that from the remote sensing data. The next, if there is ortho imagery for our location, especially leaf-off ortho imagery, that will help us get a little bit more detail under the tree canopy. And then the overarching data set that we use that's output nationally is the National Agricultural Imagery Program data set, which is 1 meter resolution, and that is output over the entire United States. That is really what we're basing on what years we are outputting from this project. So, it's split up throughout the Chesapeake Bay watershed. So New York and Pennsylvania will be having a 2017 NAIP imagery, so 2017 land cover update. That goes along with their 2013 land cover update from before, and then the rest of the states will have 2014 from before and then 2018 for this update. And they put that together in their classification software and output with a land cover data set. And of course, we will then quality assurance, quality control, the QAQC, we'll be fixing that up, of course, to make it as accurate as possible. And that is also where the stakeholder outreach will come in, and I'll be asking for feedback and input to make sure the data is as accurate as possible. And then the last step is the land use conversion. So from the NAIP imagery, that's in other data sets, we get the land cover. You can see that in the middle there, and that's basically what type of landscape, what covers the land, what consists of the landscape itself, and the classes are underneath it there. And then using planimetric data sets and other information, we will convert the land cover to land use. It's also going to be 1 meter. There's also, right now, the 2013-2014 data sets are online for download. And land use is really how the land is being used. For example, if low vegetation isn't just low vegetation, it's actually an agricultural field. That's something that would be in the land use data set, or the different types of wetlands, for example. And the land use data sets are used for a lot of Chesapeake Bay watershed modeling, such as the TMDL reduction goals, or CAST, which is a Chesapeake Assessment Scenario Tool. So land use is very helpful for certain models for that. All right, so planimetric data, this is what I've been emailing all the counties and municipalities to ask for countywide. Really, we're trying to integrate this planimetric data that counties have worked hard to create, such as parcel data, local land use, building footprints, street center line zoning, sewer service areas, et cetera, MS4s. So I've been reaching out to all of you and requesting that data. So why do we want this data? How is it useful? So on the left here is in purple, there is the most up-to-date county buildings data set, and in red is the buildings that are classified from just our remote sensing techniques. So you can see the county data set in purple is actually a little bit outdated. It looks like there were some new developments in red that have come up since they've updated the county buildings data set. So we can't just use county buildings data set alone. If we just use that based on, we would be missing a lot of development that has occurred. If we just use the structure, the imagery to create the structures, that's fine, but the planimetric data really cleans up those boundaries and borders of the building, so it really can be helpful to get the planimetric data in there. And we don't just do a blind paste of the planimetric data. Sometimes streets are incorrect or they don't line up exactly with the street. So we definitely will do some control. We won't just paste things on top. We'll make sure they overlap properly and that they're correct before just we won't just blindly paste them on top. So, but it really does help us with our land cover creation. All right, so now I'm going to go through some use cases of how we've used our data for certain projects with conservation and restoration in mind. Of course, these are environmentally focused, and I'm sure a lot of your organizations, they might have other ideas of how we could use this data for other projects, which I'd be interested to hear about. So one of our other data sets that we created is the Lidar flow path mapping, which basically we use the Lidar to create this flow path mapping. So for example, right now here's the National Hydrology data set line in red. And that in blue right now is Lidar flow path mapping. So it shows how the water flows over the landscape. So when it rains, where is the water flowing, where is it collecting, and then you can calculate the drainage area, what is all going to this one point of the stream. You can see how much land is flowing into that one point, and you can calculate how, what type of land cover, land use it is flowing over that's flowing all the pollutants, either from turf or agriculture or impervious into that one point of the Chesapeake Bay watershed. So the better data is only useful if it actually can be harnessed to inform better projects. We don't like to create these data sets and then have them not actually be useful for people, of course. So we would like it to be able to be used. So here's just one example. The goal is to identify priority locations for best management practice implementation. So here's a land cover classification. It's the 1 meter resolution. And so our goal is to identify gaps in riparian forest buffer. So each state or county, they might have different gaps that they like to look for. So for example, this is a 35-foot gap. And you're able to use land cover to identify where is there no tree canopy within 35 feet of a stream. So in pink, that's where those gaps are. Let's say we've identified an area where we would like to do a restoration project. There's two gaps on both sides of the stream here. So, and they're both about the same size, so they'd be about the same amount of money to plant trees here. So how would you identify which one is the better side to plant trees on? You would probably want to know what is the biggest impact. You don't want to just be planting trees for a lot of money and not have it actually be giving a big impact. So if you overlay the Lidar hydrology map, you can then identify the drainage area through these buffer gaps. You can see that the bottom buffer gap actually drains almost 60 acres of land to that water. So you can see, and then you can also calculate the drainage, what is the land cover it's draining or the land use it's draining. You can see how much acres of agriculture it's going over, how much turf, how much impervious. So it's about 60 acres of that will be draining into that stream, where if you plant trees, it will help filter that pollution out. And on the other side, you can see it's only 4 acres, so it's a lot bigger impact to plant the trees and spend the money on the lower half of the stream. Other types of projects that we do, including using land cover and land use, and with other variables, is assessing the landscape to prioritize parcels or conservation projects. So here we are prioritizing parcels for conservation. So you can see that we've identified and prioritized them from the highest priority to the lowest priority. Using the land cover, you can calculate restoration opportunity area, upland drainage area, runoff treatment potential, etc. and then rank prioritize based on the weight of how important those things are for the organization we are working for. And now you have a prioritized list of which ones have the highest impact on the conservation, on the restoration, to identify and contact those specific parcel owners. That's just another way that we've used our land cover and land use to help with other projects. And again, this is just another side-by-side of the 30-meter resolution land cover, national land cover data set on the left, compared to the 1-meter resolution land cover on the right, just difference in detail you can see here. And then the links are at the top again. And here are a bunch of other links that will show other projects, other web viewers. And I just wanted to mention at the bottom that the Cornell University Geospatial Information Repository is hosting our land cover data set from 2013 and 2014 online. Along with on our website, we also have the data hosted for download. And that's for 2013, 2014. And then, of course, we are currently working on the 2017 and 2018 updates. And here's my contact information with our website. Of course, feel free to email me. I've been emailing all of you and hopefully been hearing back from a lot of you. But if you have any other questions, don't hesitate to email me or call me. I'm happy to help. The links are there up there again. And that's it. So thank you so much for attending. All right, bye-bye, guys.